Now, let's check if Java is installed correctly on your system, as it's a really critical component for running Apache Spark. To do this, we'll use the command java-version in your terminal or command prompt. You might want to open that up right now. This command shows the version of Java that's currently installed on your machine. If Java is properly configured, you should see a version number popping up, which confirms that the JDK is ready for use. But if the command returns an error or indicates that Java is not found, it means you'll need to install or configure Java before moving forward with the Spark setup. So remember, having the right version of Java is fundamental, as Spark depends on it to execute its functions smoothly. Once you've verified your Java installation, you can then proceed with the subsequent steps of setting up your Spark environment. Easy, right? Now that we have Java installed and the Java home variable set, let's turn our attention to configuring Apache Spark. Next, we'll write the environment variable for Spark Home, which indicates where Spark is located on your system. If you're on Windows, you would set it to the directory where Spark is installed. For example, you might use c/spark/spark-3.1-1-bin-hadoop 3.2. This step is super important because it ensures your system knows where to find the Spark binaries, making them accessible directly from the command line. For those of you using Mac OS or Linux, we'll take a similar route by adding an export command to your .bash profile or .bashrc. This command assigns the path to your Spark installation to the Spark Home variable. Specifying this variable is crucial for efficiently managing and running Spark within your development environment. After setting up Spark Home, you'll find that you can effortlessly execute Spark commands from any command line interface, simplifying the process of running data processing tasks and enhancing your overall workflow with Spark. Now, let's dive deeper into the next steps. Let's take a look at how to configure your system's path variable to include the Spark binaries. If you're on Windows, what you'll want to do is use the command setPath equals path spark_home/bin. This command appends the Spark bin directory to your existing path. Now, why is this important? Well, it means any command line interface will recognize Spark commands, making it super easy to run your Spark applications. On the flip side, if you're using Mac OS or Linux, you'll use export path equals path plus spark_home/bin, which does the same thing. When you execute this command in the terminal, you're connecting the Spark binaries with your system, allowing you to interact with Spark effortlessly. Next up, we'll check if Python is installed by running the command python-version. This is a crucial step since PySpark, which is Spark's Python API, requires Python 3.6 or higher. If your system meets this requirement, fantastic. We can move on to the next steps of setting up your environment and really start leveraging the power of PySpark for big data processing. Just remember, properly implementing these commands ensures you've laid the groundwork necessary to unlock Spark's full potential. So let's dive in. Now that we have our virtual environment set up, let's proceed to activate it. This is really straightforward and depends on your operating system. If you're on Windows, you'll want to run a command that directs your system to the scripts folder of your virtual environment. What this does is initialize the environment, ensuring that all your subsequent package installations happen within this isolated space. Now, if you're using Mac OS or Linux, you'll employ a slightly different command through your terminal to activate the environment. This step is crucial, trust me, because it isolates your project dependencies from the global packages, which helps prevent those pesky version conflicts and makes everything much simpler to manage. With the environment activated, we can now move on to installing PySpark, which is, honestly vital for tapping into the powerful capabilities of Apache Spark within your Python projects. So, to do this, you'll invoke the pip package manager. Just follow that with the installation command for PySpark, and you'll download the latest version along with any necessary dependencies. That's it. This straightforward installation process really sets the stage for coding with PySpark, laying the groundwork for effective big data manipulation and analysis as we dive deeper into your learning journey. Now, let's check if our Spark setup is working correctly by writing a simple script. First things first, we'll import the Spark session class from the PySpark SQL module, which is essential for accessing Spark's functionality. Next up, we'll create a Spark session, and let's name it Test Spark Setup. This session is actually the entry point for us to interact with Spark's capabilities. It allows us to perform operations on our data. To do this, we'll use the getOrCreate method to either retrieve an existing session or create a new one if none exists. After we establish the session, we'll print out the version of Spark that's currently in use. This step is super important, not just for confirming that our Spark setup is rolling, but it also gives us some useful info about the version we're working with, which can be handy for compatibility and feature references. All right, now let's implement a basic data framer operation to really solidify our understanding. We'll create a data frame from a list of tuples. Each tuple will represent a record containing a name and an ID. Remember, the data framer is a key structure in Spark. It provides a distributed collection of data that can be processed effectively. Finally, by using the show method, we'll display the contents of our data frame. If everything goes smoothly, this output will show us the names and IDs, confirming that we've successfully set up Spark, and we're all set for further exploration. Now, let's see how we can set the Hadoop home environment variable, which is crucial for the proper functioning of Hadoop on your system. On Windows, you'll define the Hadoop home variable by specifying the path to your Hadoop installation directory. After that, you'll need a command to update the system path. This step allows any command line interface to recognize where Hadoop is installed, enabling you to run Hadoop commands seamlessly. For those using Mac OS or Linux, the process is quite similar, although it does follow different syntax conventions. Here, you'll export the Hadoop home variable to point to the Hadoop directory, and then you'll append the Hadoop binaries to your system path. This integration is essential because it ensures that the Hadoop tools are accessible from the command line, facilitating smooth interactions with Spark. By establishing this connection, you significantly enhance your Spark environment's capabilities, allowing it to effectively manage larger datasets and utilize Hadoop's distributed storage features. So, setting these environment variables correctly is foundational to your big data processing journey. Throughout this setup process, remember, troubleshooting is totally normal. If something doesn't work as expected, don't fret. Just hop online and search for those specific error messages. There's a vibrant community out there, and many folks have faced and resolved similar issues. It's kind of like finding treasure in a box, right? Setting up a working environment really lays the foundation for everything you'll accomplish with Spark. Once we've gotten that groundwork sorted, you'll discover that Apache Spark has incredible potential for big data processing and analysis. Now, in the upcoming tutorials, we're going to dive deeper into crafting data frames and manipulating data using Spark's robust APIs. So, buckle up. The adventure into the world of Spark is just getting started.